Hey, hello, how are you? So I decided to continue with the Python a bit. So last time I experimented with reading a file, and I created a class finder which I moved into other file, and the plan config I had, I also moved it to another file so that it would be easier for me to reason about what the hell is going on. So all my code that I had in Rust prior to that is pretty much scattered throughout different specific files. So I stopped at building a graph method, and I will go into build a graph method in here, and where I stopped here is the for loop where the key value is taken. How do I organize the code slightly better so that you don't need to see my face? All right, so now we can do this. So key action from action. Available actions, items. So I guess I was able to print it out. And I did install Python 3.8 just to have a specific typed dicts so that again it would be easier for me to reason about the code I write. This code, key and action, prints out the key and the action state it could have. Now let's comment this out. So what do we have in here? Has preconditions and preconditions met. Sorry. So has preconditions equals so what I want to have here is just check if one dict has another dict inside. So Python 3 check if dict contains dict. Is this the one? I guess this is really what I want to have. So second should contain technically the first. Dictionary view. True only if first is a subset of second. How does that work? Hold on, I actually want to see it in action. Alright. So in the root, let's have it a pass. And here, significant space. me comment this out. So a dictionary containing another dictionary is what I want to check. So has equals and has to equals to this. Second. All right. Is this how you do it? And print. Ah, come on. Print. So it's has and has to. If I run it, true and false. Just like that. So first and second. Second contains Alright. So this is this. Yeah, so my preconditions. So what does this mean? Actions. Action, I mean. This is a G action. G action. Pre-state. So the action we are looking at right now should be in the next state. So next state should contain this. So this is a dictionary of strings and bools, and pre-state was dictionary of strings and bools. So this is a larger one, the full set of this. This is the full set of this. So this is a copy, and the pre-state is just a small subset, right? So apparently this already covers my case over here, so I don't need to write the code myself. Yeah, and actually, let's see if has pre, if it will work, then I'll be so happy. Oh shit. Not supported between instances of dict and dict. What? Dict of strings and booleans. G action. Pre-state. Why is it not working? String bool and string bool. It's not different. So items. And items in here. Alright, so will this work now? Cool. So something overlaps, something is not. Awesome. So apparently if has preconditions. Sorry. Then the cost size is running cost plus action cost. Alright, so cost equals to running cost plus action dot why doesn't alright, oh, it's a dictionary. No, action pre-state, well, int. Alright, at least it's gonna work. So this is a number, start node, running cost. So this is a G node, running cost. Should I annotate it as integer? I think this is the way to go, and now running cost is int, and the type inference, yeah, worked. All right, cost is a cost. All right, if cost is more than self dot cheapest, is there a continue? So these languages are actually really similar. I mean, it's all one language at this point. So next state. Next state will be the next state base. Next state base clone. Oh, copy. So instead of clone, I use copy in Rust, in a Python. Update with post conditions. This method is used how many times? Once. All right. So so I need to update the next state with post conditions of action. So how do I do that? So copy dict into dict. So this is a copy, or no, merge. Merge dictionaries together. All right. Merge. So apparently I should be doing this. Update. Oh Lord. All right. Update. Um, Seems legit. Oh boy. Nested dictionary is not working. Yeah, I don't have nested ones. Let me check. So let me comment this out. I have 2 of these, and apparently I should be doing first. So star star first, star star, come on, second. And it should give me a, so second will have this string, and when I merge these, it will have this. Alright, so we know how to create a new dictionary based on the two dictionaries. So I copy this, and the next state is equal, apparently, star star, next state base, and star star action post state. So this gives me a dictionary of strings and bools, so it remembers. Alright, cool. Now all goals is here. Let's actually, reuse all pieces of logic I had in Rust. All goals is self config goals. Alright. So hash map contains so I need to know a function how to iterate an array. So array find, so Python 3 find in list. X for X in list. What? Alright, this is some voodoo shit. Alright. This is not readable. Python find and list. Yes. Alright. Let's remember a few things. So I am going to iterate through a list. So in order to search, I'll need to return this. right? So in the original code, I was doing matching goal, and it's an actual thing. You know what? I will actually, copy paste this. Search list of what again? A list of goals. Yeah, import it from plan config. So, and this is supposed to search for this next state. Next state, and the next state was supposed to be a dictionary of Boolean and string. Oh, big dict. All right. If list this dot, no wait, not dot. List of goals, and in the goal, so it was G in the original, like in here. Yeah, G, renamed it to G. Yeah, it will be easier. Goal index, goal, and the G state. Um, how was it done? This. So this state in the goal is this. So map contains next state should contain the goal state. So next state contains the goal state. Exactly the same way I did in here. Next state, a bigger one, should contain a smaller one, and it should be items. Don't forget the items. All right. In case of this, it should give me the list G, the matching goal. So list G, otherwise none. All right, so search for search goal. All right, it's goal or none. Nice. So now that I have this function written, I will matching, copy paste. Matching goal equals search goal in the list of all goals, and the dictionary is next state. All right. Checking for none was done like this. If it found something, so next node would be, yeah, let's copy this. Bam. So next node is G node, like this. So actually, let's copy paste this. This is exactly the same code. So next node equals G node, ID is key. So what is key? Key is from this for. So this is the key. From node start node index. Where is this coming from? Yeah, we're going to rely on it being in integer. Yes. So from node is covered. State is the next state. So next state, copy, and the cost. All right, and apparently this is not needed anymore, so it's literally this next node. Bam. All right, so after this is covered, adding this to there. If G not equals to none, matching goals, sorry. All right, so this is the syntax. Then another if self cheapest more than cost. Existing size, existing, wait, existing size is going to be self nodes, self nodes. I guess I saw that there is a method len for nodes -1, and the leaf is going to be existing size. Of course, the self cheapest is going to be a cost. Alright, this is it for this if statement. So matching goal is not a none. Alright, so else oh come on, else Next available actions is available actions. Is it copy? Yes, copy. All right. Next available actions is there remove. Update, I see an update. So Python 3 dict remove key. How to remove a key from dictionary? So much text for literally, I guess, one. Yeah, this is not possible. Come on. Pop key. To delete a key regardless of whether it's in dictionary, use the two argument form of dict pop. To delete a key that is guaranteed to exist. All right. So pop a key. I know a key name because it's in the for loop. All right. So this apparently is, yeah, this. Leave internal. Leave, let's copy paste that. Leave internal is going to be self build graph. So start node index is going to be length of self nodes, apparently -1, and next available actions. All right. So yeah, after this build graph has returned something, we should check if it returned anything at all. So if this is either none or something else. All right, so if leaf internal is not none, then leaf is leaf internal. So that's quite a mouthful of logic, and after all that, we should return after all that, we should return that leaf. Here, return leaf. So it's either int or any or none. What the hell is going on in here? I'm not sure. Oh, because yeah, in the Rust code. Okay. I'm not sure how to read that code myself anymore. Anyhow, there's my leaf, and hopefully if I am able to get at least something in here, then I'll end the recording. 7. Oh, okay, it worked somehow. So after, so this is supposed to be inside the execute method. Print leaf, this is what we saw. So this is the build graph, and this is the build graph here. Let's quickly try to build this. Index option. Okay. Copying here. So index option is going to be a leaf. I'm going to set up leaves, vs as a list of string, a star. All right. So while index, all right. So for how do I do this? Like, is there a while in Python 3 while loop? While something, do something. All right. While, so index option, idx option not equal to none. Leaves, add, append, self nodes index. So it's index option idx option dot id. Cool. So this was added, and the next index option is self nodes add index option from node. So this is a G node. G node index is didn't I initialize something with -1? Oh, this is gonna be a none. All right. And the next G node we created was their integer or this. So the ID is supposed to be an int or none. Can I do that? Is this? How do I? But the leave here was this or this or this. Any 4. All right. You know what? F it. Let it be just an integer, right? I'm quite sure. Well, this is not saying that this is not correct. All right. So this will at least not fail, and it will encounter a none. IDX option is this. So from node G node is going to be an int. And this was a stir. Yes, the ID was stir. Anyway, uh, from node integer. Good God, this is hard. I mean, the languages are there to help you, but if your skills of coding are not that good, then um, coding is hard. So finder, execute, bam. This was supposed to run like this, and this should return this. So execute, and execute should let, oh no, sorry. Result equals to this list of strings, and let's print result, and hopefully I'm not gonna crash anything. All right, so I did end up having something, and it should be reversed. um, how do I reverse oh, reverse. So I'm actually wondering what, a none. Oh, so leaves. It does it mutate the original list? There we go. So eventually what we see in here is the algorithm actually tries to, from start node, with initial data, it sees that it should search for a weapon because it does it have a weapon? Nope, it doesn't have a weapon. It will pick up a weapon so that we get a weapon. Will it have a ammo? Nope, it doesn't have ammo. It searches for it. It picks it up, scouts with a weapon, finds, so scouting with a weapon, scouting with a weapon. Eventually we'll see an enemy in here. Then we start aiming, and aiming only starts if the enemy is visible and it's not on the line of fire, and if we aim like snipers, then eventually the player will be on the line of fire, and then we attack with a weapon, and it will make an enemy alive false. So obviously you don't see an enemy anymore, and no one is on the line of fire. There we go. We created this thing. So if we make, for example, um, searching for a weapon way too expensive, I guess the algorithm will make, yeah, it will just change the mood, and it will not try and so this will be basically um, the main cheapest action we could implement. We just don't want to attack anyone. Ready for peace means that our character is probably not gonna uh, enter a combat. It's not supposed to, it knows it will not win, so it's ready for peace and negotiate, and it will just say, all right, this war is stupid. Let's just, you know, find some inner peace. But if it's still cheaper to attack, then it will attack with a range of actions. Whew, done. Thank you for so much for looking at this, and see you next time.